uppermost part of the Earth's crust. It's where plants grow, it's where food grows, and it's also home to many different living things. The little worms that we like to pull out, lots of bacteria and fungus also live in soil. Soil is made up of only 4 materials. In soil, we find air, water, minerals, and organic materials. Organic materials just being the dead leaves and other living and non-living items. There are 3 types of soil. What type of soil you actually end up with or what types of plants grow in soil is actually based on the mixture of these 3 types of soil. So if you have a type of soil with lots of sand in it, it's actually considered a sandy soil. And there are certain types of plants that like to grow in that. If you have a soil with lots of clay in it, it's called a clay-based soil. The 3 types of soil here are sand, silt, and clay. If you notice, sand actually has quite large particle sizes. What that allows is it actually allows for lots of water to flow through here. So it can take lots of avenues because those spaces in between the particles are bigger. Once we start getting into the other ones, the particle sizes get smaller and smaller. So silt, because the particle sizes are smaller than sand, it takes a little bit longer for this water to kind of find its way through these little tunnels, if you will. If we were to pour water through this stuff, it would take a little bit longer to go through that silt. Lots of time we find silt in ponds or at the bottom of lakes. We're gonna test these 3 types of soils to see how well the water goes through them, but silt we won't test just because I don't feel like going swimming. And last one we have here is clay. You can see how tiny the particles on this clay picture is. The water takes way longer to kind of navigate its way through all these little particles. Even me drawing it takes a little bit longer, right? Clay actually holds on to water better than silt would, and silt would hold on to water better than sand would. In order for soil to be created, rocks actually have to be broken down into smaller and smaller particles. Again, like we said, soil is made out of minerals, organic materials, water, and air, so those minerals actually come from rocks. On this rock in particular, we can actually see evidence of this rock being broken down. Of course, it takes many, many, many years for that process to actually happen, but eventually this rock will turn into soil. There are a couple ways that's happening. One of them is through water. So if you folks think of erosion, right? Erosion over time breaks rocks down, okay? Because of that pressure, that washing away. But also too, water when it freezes can help to break a rock down. When water gets into these cracks and crevices within this rock, and then it freezes, because that water, when it freezes, it expands, it can actually push that rock apart. Another way that this rock is currently being broken down is by plants. So this stuff here is called lichen, okay? And lichen doesn't need a bunch of soil to actually grow, so it finds itself on this rock, and there's a chemical within the lichen that actually breaks the rock down. Over time, underneath this lichen will be a little bit of soil. Once there's a little bit of soil, other types of plants can then grow. If you folks can see the moss here, so the moss would be kind of like a next step to what can grow in the amount of soil that's actually provided here. But then if you look over this way, we can see more and more plant life growing right on top of this igneous rock. Another way that rocks can be broken down is by plants themselves. Trees, once they kind of drop their seeds, if it's on a rock, that seed will start to sprout, it's gonna start growing roots, and those roots often find themselves in the cracks and crevices of these rocks, and will slowly push those cracks open wider and wider. All right, what we're gonna do is we're actually gonna do a permeability test. What that means is just we wanna see how much water will actually run through the soil and how quickly. What that will tell us is how big those particle sizes are. So the bigger the particle size is, the more water that will run through that type of soil. What we need for this experiment is just an old spaghetti strainer, so a colander, 2 bowls that are exactly the same size, and a little shovel. I did bring this little Nalgene along just to hold some water so I don't have to keep coming back to the lake. I can just carry it around with me. What I want to do is I want to fill one bowl with water, and the closer to the top I can get it, the better, because then I can measure it a little bit easier. And then the other thing I want to do is fill the container just kind of like 1/3 of the way up with the type of soil that I want to test. So here I know this is sand, and what we're going to do is we're actually going to compare it with clay and loam later. So I'm going to fill this 1/3 of the way up. You don't necessarily need to pack it in. If you just lightly scoop it in 1/3 of the way. And then what I want to do is I actually want to pour this water slowly through the soil sample. And I want the water that comes out of the strainer to land in my empty bowl. We're going to do it slowly. Maybe we'll count to 30 so that it'll be even for all soil samples. There's 1, 2. All right, so what we have here is again our sand sample, and we started off with a full bowl of water. And if you folks look at this bowl here, it looks like we got most of that water back. If you're ever out playing on the beach or making a sandcastle, pick up a handful of sand and just experiment with how it feels, or maybe check out the colors in the sand itself. Sand is made up of mainly broken down minerals or rocks and lots of shells from animals that live in the lake. Sand also has less organic materials in it than other types of soils, so not a lot actually grows in sand. Here I have clay. Clay is one of my favorite things because you can play with it. You can make all kinds of cool little figurines because it molds really well. This stuff I found actually in this hole here. So this is natural clay. Clay has the smallest particle size when we're talking about the 3 types of soil. So sand having the largest and clay is on the other end with the smallest particle size. What that means is that water won't pass through it very well. We'll do the test here in a second. Clay, it kind of holds on to water. There are only a certain amount of plants that like a lot of water. There are only a certain number of plants that will actually do well in an area that has lots of clay. Clay, too, if you mix it with sand, it's actually how you get bricks. So we use clay and sand, we mix them together in a factory. That's how bricks are made, so that's kind of neat to think about. We just talked about sand, and now we're talking about clay. So I'm gonna fill up my strainer again, 1/3 of the way with clay. I'm gonna fill 1 bowl full of water. And then I'm gonna place my strainer of clay over top of my empty bowl. And then I'm slowly gonna pour the water through the clay. As you can see, we actually ended up with less water that time. So less water was actually able to go through the clay. Another cool thing is that clay back in the day was actually used for pottery. So people would collect water, hold water, even build huts, right? Like homes with clay. So they would use clay on the roofs of their homes because it didn't allow a lot of water through. So what I'm gonna just do here is make a little bowl out of this, just to show you how well it holds the water. Okay, just gonna pour a little bit in here. Okay. So if I was brave, I could drink this, but the water came out of the lake, so I'm not going to. The clay is holding on to that water quite well. We're sitting in the middle of a forest, so again, we're at Gould Lake Outdoor Centre. On the forest floor here, we actually find loam. Loam is a healthy combination between sand, silt, clay, and organic materials. So the organic materials is just the dead, decaying leaves or the little critters that are moving around in here. What this does is it actually provides a really great environment for lots of plants to grow. If you take a look around, there are a ton load of trees in this area. Loam, when we put this water through, it's probably gonna hold on to some, but then also let some drain out because, again, it has all three of those different types of soils in it. The sand in it will allow some to drain, and then the clay might absorb some, like hold on to some, and then the organic material kind of acts as like a sponge. It's going to hold on to a lot of that moisture, which then allows those plants enough time in order to absorb that water from the soil itself. So I'm going to do this experiment. I filled up my strainer 1/3 of the way, and then I'm going to place my empty bowl underneath, and we're going to count to 30 one more time. 1, 2, 28, 29, 30. You can see that some of it actually ran through this soil. I do like to get my hands dirty, so I'm going to show you how much this loam actually held on to. But if I squeeze this, I can probably get quite a bit more water out of it. It goes to show how much this soil actually holds on to.